Okay, number one, these are 61 questions that we're going to use to study with for the midterm. You have numbers, you have the i's. You want to just drop the parentheses from the first one, -6 minus I plus 5I. The trick here is the negative symbol outside of the parentheses tells us to distribute. So this should be -11 minus 13I. When you go through, you have -6, you have a -11. That gives you -17. And then when you look at the i's, you have -I plus 5I is 4I. And 4I minus 13I is -9I. So looking at your choices, if you have them in front of you, it's the first one, -17 minus 9I. Number two, they give you 4/9 and it's raised to the 1/2 power. The question says which one is not an equivalent form. So we're going to run through all of them. First off, when you have something raised to a power and it's a fraction, you want to raise the top and you also want to raise the bottom. And we know that the 1/2 power means the square root power because it's power over root. Raising something to the first doesn't change it, and then the root is 2 on each of these. So in our mind, we're thinking about this as the square root of 4 over the square root of 9. So if we look at your choices, that's the one I just described for choice F is the square root of 4 over the square root of 9. So that one's equal. For G, they have 4 over the square root of 9, and that's going to be the one that's not equal because you end up with 4 over 3, whereas up here this would be 2 over 3, which is what we were thinking about with the square roots. Looking at H, it's a big square root of 4/9. And whether you do a big square root of 4/9 or individually the square root of 4 over the square root of 9, these mean the same thing. And for the last one, choice J, they just give you 2/3, which is the result of the square root of 4 over the square root of 9. We're looking for choice G. Okay, for our third one, it says essentially which value, when I plug in for B, allows this thing to factor. And the choices are tricky, so you have to be careful. So I want to try each one individually. If I try 61, I would have x squared plus 61x minus 60. Looks like it might factor because in your head you're thinking 60 times 1 is 61. So I try to factor it, and I would say x, 60, and 1. And you know you want a positive 61, which means these both would have to be positive. Problem is that a positive times a positive does not give you the -60, so 61 is wrong. That doesn't factor. You go to the next choice, and to save time, I'm not going to keep doing them, but 23 would do the same thing. It does not factor. When you try choice C, the -7, you end up with x squared minus 7x minus 60. When you factor, you have x and x. Factors of 60, difference of 7, 12, and 5. I'm looking for a -7, so minus 12 plus 5. And then if you go to FOIL this out to check, first times first is x squared. The outer is plus 5x. The inner is minus 12x. That gives you your -7x. And last times last is a -60. Number 4, they ask you to factor. You see two terms. Hopefully you see this is the difference of cubes. X to the third is a cube. 216 is a cube. To factor this, you make 2 sets of parentheses, a small one and a big one. We put the symbols in, and we say same, opposite, always positive. So to do these, you take the cube root of each. That would give me x, and the cube root of 216 is 6. I square the front term, I square the back term, and I multiply these two right here, and my final answer is x minus 6, x squared plus 6x plus 36. The next one asks you to graph the absolute value. They give you choices to match up. We'll just sketch this one for ourselves. So they want you to match this to the absolute value of x plus 1. So we know the absolute value of x is the shape of a V. If there was a left and right shift, it would have been in the brackets. So there is no left and right shift, and it's shifted up 1 unit. So we know we're at nothing left and right, and we're 1 unit up. And we have a V. In this case, it's a dotted V. And to finish the problem, you're looking between now choice A and choice B in your packet. This says less than. So when we say less than, we want to shade down. If this had said greater than, instead of shading below the V, we would have shaded up top above the V. Okay, the next one is a variation question. So we start to read, and the first part of a variation question is you want to determine what type of variation you have. So my first scan through, I'm only looking for the word direct, inverse, or jointly. You start reading, and you get to something is varying inversely. So in your mind, you have a letter is equal to k over another letter. And we start over and say, what letters do I have? It says a farmer pumps water from an irrigation well. So the first thing, the time varies. So time varies. T equals, and we know it's k over, and we keep reading. What does it vary inversely with? The rate. So time is equal to k over r. That's the first part. Find an equation, then solve for k, and then answer their question. So we have an equation. Next part. It takes 20 hours. Hours would be a time. So 20 is equal to k over, what is our rate? 20 hours when the rate is 600. So 600. If I want to solve this for k, 20 is equal to k over 600. You would multiply both sides by 600, giving you 12,000 is equal to k. Be careful, because sometimes 12,000 would be a choice in here. They're not asking you to find k as a final answer. You just need k in order to answer the question, which we will do over here. And it says, if he adjusts the pump so that the rate is 400, how long will it take to water the field? In other words, they're now telling you that the rate is 400. They want us to find the time, but you know what k is because we just found it over here. It's 12,000. And 12,000 divided by 400 is choice H, 30. Okay, for the next one, we are multiplying. So since it's just fractions and they're being multiplied side by side, we want to multiply the top times the top and the bottom times the bottom. 3 times 5 is 15. 10 times 3 is 30. So in your mind, you're thinking about 15 over 30, which is really 1 over 2. I'm going to look at the letters. The x on the bottom is going to stay because there are no x's up top. There's nothing to cancel with. The y's, there's 1 y up top and there's 4 on the bottom. So if you have 1 up top and 4 on the bottom, there's more on the bottom. So you would be left with 3 y's on the bottom. If I look at the letter z, there's 4 of them up top, 1 of them on the bottom. There's more up top. So when you cancel, you're going to be left with z up top. In this case, there would be 3 of them. Choice A. Next one says, which expression is equivalent? We have roots on both sides. You're subtracting, so in order to do that, you need to get the same number underneath. We want to make 75. 25 times 3. And 27 is going to be 9 times 3. The square root of 25 is 5. The 3 is going to stay. The number in the corner, it's a square root, so even though it's not written, it's a 2. 2 goes into the exponent of 3, once remainder 1. The square root of 9 is 3. The other 3 will stay. Same deal in the corner as a 2. 2 goes into the exponent of 3, once remainder 1. 5x minus 3x is 2x. Square root of 3x, choice D. Going to the next one. Which number is equivalent to 32 to the 3 over 5? 32 to the 3 over 5. This is power, and this is your root. You want to do the root first. The 5th root of 32 is 2, and you take that number now to the 3rd power, and 2 to the 3rd power is 8. Next one, you have something up top that can factor. You have something on the bottom that is already factored. And in other words, I just want you to factor and cancel. So I look at the top and I say I have an R and an R. Last times last has to be 6, and at the same time I want a negative 1 in the middle. So I'm thinking a 3 and a 2. Again, I want a negative 1 in the middle, so I'm going to let my 3 be negative and my 2 be positive. On the bottom we have R minus 2 and R minus 3. The R minus 3's cancel, leaving us R plus 2 over R minus 2. First choice. The next one is the absolute value of X minus 3 is less than 5, so we definitely know how to solve it, and then we just want to be careful when we match it to a number line. So to solve this, it's x minus 3 is less than 5, and x minus 3 with a negative 5, and we flip the symbol. So when you solve these, you add 3 to both. X is less than 8, and x is greater than, add your 3 over, negative 2. So you have two answers, and now we want to see which number line represents less than 8 and also greater than negative 2. So I come over here, I look at this one, it's an 8, but this doesn't say less than 8 because it's going towards the right. That would mean greater than 8. That one's gone. This one down here is not at 8 at all, so that one's gone. Same thing, not at 8 at all, that one's gone. And this one here, x is less than 8 because from right here it's going to the left. And over here at negative 2 it's going to the right. That would mean greater than 2. Choice D. Identify all points on the graph where this thing is hitting the x-axis. Two ways of doing it. First way I'll show you is algebraically. We can take each one of these things and set them equal to 0. So you can take x plus 1, set it to 0. And this other one here, x squared plus 8x plus 16 factors into x plus 4, x plus 4. And it's the same quantity, so when we set it equal to 0, you're going to get the same exact answer. So you're going to have x is equal to negative 4, x is equal to negative 1. If it hits the x-axis, it's an x-intercept, so it's negative 1, comma 0, negative 4, comma 0. We set it equal to 0 because if it's hitting the x-axis, that means y has to be 0. So algebraically, that is how you do it. If you don't like that way, you can grab a calculator and graph this exactly as you see it. And when you were to look at your graph, try to sketch something up here. So this is not perfect, but at negative 1 and at negative 4, in some way or other, the graph would have hit at those 2 points. And I don't know that that's the exact graph, but you would have had a cross or an intersection at those 2 points. So you could graph this on your calculator and just look for yourself and match them up with the choices that they give you. In the next one, it says, which of the following is equivalent? So we have two different square roots. We see a negative symbol underneath, so you know that the letter I is going to be involved. I break each one down and say that 72 is 36 times 2, and I'm just keeping that I in my mind for whenever I pull the 6 out from the 36. We're adding. 50 is going to be 25 and 2. The square root of 36 is 6. And again, we said there's an I in this because they were both negative. So 6I. Root 2 plus 5I. Root 2. Again, the I coming from the negative. I now have the same number underneath. We add them up and we have 11I root 2. Final answer, choice C. Which expression is equivalent? They're asking you to factor. You see 64 x squared. You see 81 y squared. 64 and 81 are both perfect squares. X squared is a square. Y squared is a square. They're being subtracted. Everything is a square. So difference of squares. To do difference of squares, it's square root each with a plus. Same exact thing with a minus. Choice H. For the next one, it says the function 1 minus x quantity squared minus 4 is decreasing. This problem says, what's the decrease? You have a quadratic, so you know you have the shape of a U. You say, what value would make this 0? 1 minus 1 would make this 0. So this is 1 unit to the right. You're up and down, you keep 4 units down. So in your mind or on paper, you're looking at 1 unit to the right and 4 units down. So roughly, that is the shape of your graph, a U. And when you're doing the increase and decrease, we only care about the x value. So the way we learned this was there's a guy running, and he runs from negative infinity to infinity, and as he runs, we see what happens. So as he runs from negative infinity, this graph originally is going down, and it continues to go down until he has run to the number 1, at which case it stops going down and then turns into an increase. So we can look at both intervals here. The decrease is from negative infinity to 1, and then the increase is from 1 to infinity. This particular question said, what is the decrease? So the decrease would be from negative infinity to 1, choice B. Point A lies on the graph of, we don't really care what the equation is, but it says to locate the image of point A that lies on the graph of. The key to this is knowing, and I'm going to write it bigger here, that f negative 1x. That right there means the inverse. So you have to review what an inverse means to you. An inverse means to take the x and y and switch them. If they're asking for the equation, after you switch it, you solve for the new y. In this case, it doesn't ask for an equation. It's saying, what would the coordinates be of this point on the inverse? So you look at point A, and you see that point A is at negative 2 comma 1. If it's at negative 2 comma 1 on the original, on the inverse, you would take that pair of points and flip it. So it would be at 1 comma negative 2. On the SOL, they would have you click on the graph and plot that point. Next one. They give us something in a radical, and they're asking us to switch it over to exponential form. So the fourth root of 16 is my first part. The fourth root of 16, you want to go slow. It's not 4. The fourth root of 16 is 2. And then for each one of these, we're going to exponential form. It's x to the power over root, y to the power over root, and whenever you put them together, you have choice D. Next one, they ask for the x-intercepts. So before we do this problem, we want to know that x-intercepts means the same thing as roots, zeros, answers, solutions. They could have asked for any one of these things. Intercepts, roots, zeros, answers, solutions. It all means where does the graph, in this case it's a parabola, where does it cross the x-axis? You have two main ways of doing this that we've done. Factoring and quadratic formula, right? You can also look at it by graphing on a calculator. We're looking to see where it crosses the x-axis. This is a nice one because it factors. If you are not comfortable factoring this, you could do the quadratic formula, but this one would factor into x and x. We know last times last is 15, and I want 8 in the middle, so 5 and 3. I want what kind of 8 in the middle? A negative, so these are both negative. I want a positive 15 at the end, which a negative times a negative creates. To find the intercepts, you're setting this equal to 0, because that is what y would have to be if it's going to hit the x-axis. X minus 3 equals 0, add 3, x equals 3. X minus 5 equals 0, add 5, x equals 5. Now you have to look at your choices because you are looking for x-intercepts. If it's an x-intercept, the y value has to be 0. So you are looking for 3 comma 0 and 5 comma 0, choice B, which is equivalent. This problem says to multiply. It means to FOIL this out. First times first is 30. The outer is 6 root 7. The inner is 5 root 7. And last times last is a radical times a radical, same number. That radical goes away. 30 plus 7 is 37. And 6 root 7 plus 5 root 7 is 11 root 7. Last choice. Okay, the problem asks to find the end behavior. It says the end behavior as x approaches negative infinity. So this is our EB question from when it's one of my tests. You're saying, in this case, only as x goes to the left. And when you look at the question, it says negative x to the 7th. We don't know what bx is. I don't know what c is. So I'm going to throw those away, and I'm just looking at negative x to the 7th. You have y is equal to negative x to the 7th. So you want to turn your graphing calculator on, and I will serve as your graphing calculator for right now, but you would want to graph this, and you get something that looks like that. And now we're looking as x goes to negative infinity. That would mean as x goes all the way to the left, I want to know what y is doing. Choices are c and 0, which make no sense, and it is going straight up in the air. So as x goes to negative infinity, which is this way, y is going up. Answer, choice C. Next one says, which is a 0 of the following? If you are looking for a 0, you're looking for a root, an answer, a solution, an x-intercept. You're looking for where this crosses the x-axis. Choices are, you could factor this. Might be a little confusing though with the 6 out front because you have different choices. Other option is hop straight to the quadratic formula. Either or, you're going to get a 0. If we factor this, I would try 3x and 2x is 6x squared. I'm looking for, again now, factors that give me 6, 3, and 2. So I look at my setup here currently. First times first is 6x squared. The outer is a 9. The inner is a 4. They're both with an x. 9x and 4x does create 5x. I want my 5x to be positive, so the 9x is a plus, the 4x is a minus. Last times last gives me what I wanted. Now, I made that look easy because I've done this problem a bunch of times. I knew exactly what it was, but there's a bunch of combinations that could have got you there. So you might not want to start this one with factoring when you see that there's an even number out front. You might want to go right to quadratic formula. So if you wanted the quadratic formula, we'll finish this first. So this would be 2/3 and -3/2. If we went to the quadratic formula, it'd be negative b, so -5, plus minus the square root of b squared is 25, minus 4ac all over 2a. So we're going to say, what do we have here? -5 plus or minus, -6 at the end here. 25 minus 6 times 6 is 36. And what? 36 times 4 is 144. How many minuses do we have underneath? Minus minus makes a plus. So 25 plus 144 is 169. This would be, which is good, as a perfect square. -5 plus minus the root of 169 over 12. The square root of 169 is 13. So this is -5 plus 13 over 12 and -5 minus 13 over 12. We want to find the two answers. -5 plus 13 is a positive 8. 8 over 12 is, same answer we already had, right? 2/3. -5 minus 13 is a -18. -18 over 12 is a -3/2. So you got the same two answers. It's just whether or not you were able to do it through factoring or quadratic formula. Now back to the actual question. It says which one is a 0. Doesn't say that they're representing both of them, so you're looking for one of these choices to show up. If I look for 2/3, no. That one's -2/3, close, but that's not it. No and no. Is there a -3 over 2? Yes. So the overall answer to that is choice F. Which of the following describes the roots of the equation? Before we get into describing them, we need to solve this for 0. Let's get everything to the left. So this is 9x squared minus 6x plus 1 is equal to 0. So they're asking us to describe the roots. So let's run through all of your scenarios. You can have a graph that looks like this. It crosses the x twice. So in terms of a graphical approach, if that's your graph and it crosses twice, you have two real answers. If you're looking at it in terms of the quadratic formula, you have -b plus minus the square root of 2a. The part underneath the square root, if you're going to get two answers, has to be a positive number. Doesn't matter what the positive number is, but that's what would give you two answers. Plus this, minus that, you'd have two real answers. If you were to graph this and you have only hitting it once, you can look at it graphically and say I have one real 0, or if you're in the quadratic formula, -b plus minus the square root of, if I only want one answer, the number under the square root has to be a 0, because -b plus 0 over 2a, whatever that might be, and -b minus 0 over 2a, if I add and subtract 0, I have not changed anything, right? So that's how you get one answer that's the same. Graphically, it would be 1, 0. Through the quadratic formula, you have a 0 under the root, so this would be one real answer. If you graph this and your parabola is out in space somewhere and it never crosses, you have no real answers. So what do you have? If you looked at it through the quadratic formula, you would have -b plus minus over 2a the number underneath the quadratic would be, if I'm going to have a not real answer, that means it's imaginary. It means the number underneath is a negative number. So if you have a negative number underneath the quadratic, it's still going to be plus minus. So you got two answers. It's just they're two imaginary answers. So let's look at our choices one more time. You could have it crosses the x twice, positive number underneath the root. You'd have two real answers. You could have hits the x once, zeros under the root, plus or minus 0 is the same thing. You have one real answer. You could have this out in space. It doesn't cross anywhere. Negative number under the root. You have two imaginary answers. So now back to our problem. I know right away choice C is wrong. There's no way to have one imaginary. So that's gone. You then would want to, you have two ways to do this. You could graph this, see which picture you get. Does it cross twice, once, or never? Or you could use the quadratic formula and see, do I get a positive number under the root, a negative number under the root, or do I get 0 under the root? I will save you the time here to keep going, but if we did negative b plus or minus everything, you get a 0 under the root, or you would have a picture that looks very similar to this one right here. So you would be looking at choice A. On to the next one. It says the cube root of 162 x to the 6th y to the 7th. So we have a cube root. It means you want to think of your perfect cube roots. So cube roots would be 1, 8, 27, 64, 125, so on. And you want to know which one of these perfect cube roots goes evenly into 162. And that would end up being 27. It goes in 6 times. So you want to rewrite this as 27 times 6. Rewrite the letters, x to the 6th, y to the 7th. So we say, what is the cube root of 27? The cube root of 27 is 3. The 6 is going to stay. It's the cube root. So now we have the numbers taken care of. To do the letters, you divide the index number in. The index number is our cube root. It is a 3. 3 goes into 6. Twice, no remainder. 3 goes into 7. Twice, remainder 1. So if this is one of my tests, that's good right there. But in this SOL format, they're asking you to write the letters out here for the stuff that would be out front, and the stuff in here for the ones that would be underneath the root. So for out front, you're looking for a 3, which is A. You're looking for x squared, which is E. And you're looking for H, which is your y squared. Underneath is 6 and your y. Which expression is equivalent? This is written in exponential form, and we are going to radical form. So let me rewrite this so that you can see it. It's a little blurry. X to the 3/7, y to the 36/7. So this is, when you have a fraction, it's power over root, power over root. The root in both of these is the 7th root, so I know I want a 7th root of x to the 3rd, y to the 36th. And then I go to look at my choices, but I don't see that. We could simplify this and say, okay, 7 goes into 3, it doesn't. 7 goes into 36, it goes in 5 times, the x stays. 5 times remainder what? Remainder 1, and that was x to the 3rd. Choice, what do we got? Y to the 5th, choice this one, C. The next one says, what is the vertex for this function? This is a U, it's a parabola. It's a parabola that is shifted 4 units to the right and 1 unit down. So if you want to sketch that, you can, but it is 4 to the right, 1 down, which should tell you that your vertex is at choice C. Okay, the question asks you to find each x and y intercept. So there is a long way of doing this algebraically, but we're not going to look at that. We're going to just look at this by using a calculator. So on your calculator, you want to turn on the calculator and graph x to the 3rd plus 3x squared minus 4x minus 12. And when you do that, you are looking to find every x and y intercept, and it will pop right up. So I don't have it in front of me, but an x-intercept, I'm just making this graph up, would be right here, would be an x-intercept, right here would be an x-intercept, right here would be an x-intercept, Anywhere that it hits the x-axis is an x-intercept. Anywhere that it hits the y is a y-intercept. Now we can look algebraically. If I want to find the y-intercept, I just let x be equal to 0. So I know right away that the y-intercept is at 0, negative 12. And then to find my x-intercepts, we're going to go on the calculator. You would have to go through and graph it, and then you look them up. For the one below it, this says click and drag. So they give you a bunch of choices, but I wouldn't really necessarily pay attention to the choices. You're just trying to factor this. It's 8x squared, so let's start with that. And I'm going to go with 4x and 2x. And then my back number, last times last, has to be 5. So I know it could be 1 and 5 or 5 and 1. There's also a y with it. I'm trying to make 18 in the middle. If I put a 5 and a 1 here, pretend to have a y with it, the outer is 4 and the inner is 10. But then you ask yourself, can 4 and 10 make my middle term? You should say no. See, it says, all right, that's wrong. So let's try 5y and 1y. Now my outer is 20xy and my inner is 2xy. Can 20 and 2 make what I want? What I want is a negative 18. Yes. How do I make negative 18? By letting the 5, which is really here now 20, be negative. That one's positive. And now you go back and look up your choices. So this would be first times first is 8x squared. Check. The outer is minus 20 and the inner is plus 2. Minus 20 plus 2, check. Last times last is minus 5y squared. Check. So 4x plus y is choice D. 2x minus 5y is choice B. A polynomial function has a 0 at x is equal to 3. Which of the following expressions must be a factor of the polynomial? So, I'm not looking at this question at the moment. If I tell you this, x squared minus 16, this would be my problem. This is the function. If I was to factor this, it's the difference of squares. So I would say x plus 4, x minus 4. I just factored this, so these are called the factors. And then if I set my factors equal to 0, I would have negative 4 and 4. These are the zeros, roots, solutions, answers, intercepts. So if I had a 0 at 4, the factor before I solved for the 0 is the reverse of that. That would be x minus 4. Same thing with negative 4 is a 0. That means its factor had to be x plus 4. So as far as this problem goes, if I have a 0 at 3, before it was a 0, its factor had to be x minus 3, choice A. Down below, all the choices equal to I. That is our chart, and our chart is 0, 2, 1, 3, 1, negative 1, I, negative I. I'm going to divide by 4. Remainder, answer. So, we're looking for a remainder of what? If I want I, I'm looking for a remainder of 1 after I divided by 4. So I divide these each by 4. The first one doesn't do it. Second one doesn't do it. Third one, you divide the 9 by 4. Remainder 1. Check. 72 is divisible by 4, so 73 would have a remainder of 1. Check. 83, 4 goes into 80, so that one doesn't do it. And choice F, 4 goes into 4, so that would have a remainder of 3. Okay? So C and D. Which is equivalent? So you're trying to add and subtract radicals. To add or subtract a radical, you need the same number underneath. So I want to take the 27, I'm going to make it 9 times 3. So this is 2, 9 times 3, plus for the 75, we're going to go with 25 times 3. So this is 3, 25 times 3. For the 18, 9 times 2. The square root of 9 is 3, and 3 times 2 is 6. The square root of 25 is 5, and 5 times 3 is 15. And the square root of 9 is 3, and 3 times 2. So the number that is left underneath in the third one is not the same. So for the first two, you have 6 and 15 is 21 root 3 minus, the last part just stays, it's stuck, there's nothing to be done there. Choice C. What is the solution set to you should be able to say that this problem is quadratic. Any problem that's quadratic, you're either hoping to factor, or if not, quadratic formula. Before you make that decision, though, you want to take everything to the left and set it equal to 0. So I have x squared. I'm going to bring the 4x over next because you want the x term to be in the middle. So plus 4x minus 16 is equal to 0. You might want to try to factor it, but then you discover it does not factor. So quadratic formula, negative b is negative 4 plus or minus the square root of b squared is 16 minus 4ac over 2a. Next thing I look at is how many negative symbols do you see, and I see 2 of them. So 2 negatives mean that I'm going to make a plus. So 16 plus 4 times 1 times 16, 4 times 16 is 64. 16 and 64 is 80. So this is negative 4 plus minus the square root of 80 over 2 is equal to negative 4 plus minus 80 breaks down into 16 times 5. 16 times 5 would really be 4 root 5 over 2, which is a good answer, but probably multiple choice. So I need to divide everything out there by 2. Final answer, negative 2 plus minus 2 root 5 over 1, or just negative 2 plus minus 2 root 5. Which function is the inverse of the following? If I'm looking for an inverse, we've got to know what the definition of an inverse is. An inverse means to flip the x and y and solve for the new letter y. G of x means y, so off the bat we have y is equal to x to the third plus 11. If I want to find the inverse, I switch the x and y. So this is now x is equal to y to the third plus 11. Solve for the new letter y. I get rid of the 11, so I have x minus 11 is y to the third. And I don't want y to the third, I want y. So I'm going to take the cube root of each. If I take the cube root of the right, it goes away. On the left, I would now have the cube root of x minus 11 is equal to y. Choice A. Looking at their choices, see how they all say g negative 1 of x? Anything with a negative 1 up there means to find the inverse. Whether it's f negative 1, g negative 1, the negative 1 means the inverse. Looking at the next one, it says, what is the solution to? It's an absolute value. We know how to solve an absolute value. That means the stuff in the brackets to the number and also to the negative number, flip the symbol. So let's get our 2 answers. This would be x plus 4 less than 2 and x plus 4, flip the symbol, negative 2. Subtract 4 from each gives us x is less than negative 2 and x is greater than negative 6. We're looking to see which choice over here matches that. So in this case, the x is being pointed at with the negative 2. So if I look at this choice and forget about the 6 right now, x is being pointed at with the negative 2. If I look at the negative 6, x is greater than negative 6. Let's look the other way now. X is greater than negative 6, so it's pointing away from the x. That's the only choice where both sides of it match up correctly. You're looking for the second choice. The graph of the function g is shown on the following grid. So they give us a graph right here, and they say that this is g. Which graph best represents the inverse of g? So if you're talking about an inverse, you're always talking about switching x and y. So I look at this graph and I say, well, which point can I definitely identify on this graph? And they give me a dot, and that point is at 4, 0. So if I know 4, 0 is on the graph of my original g, on the inverse, I need to switch the x and y. That's our definition of an inverse, telling me that instead of 4, 0, there must be 0, 4 somewhere on that graph, and choice C is the only one with it. What is the solution for the following? We have a cube root. So to undo that cube root, we want to raise both sides to the third power. 4th x plus 3 is equal to 2 to the third is 8. I subtract 3. Fourth x is 5. I multiply by 4, and x is equal to 20. Throughout which of the following intervals is the following only decreasing? This asks you to find the decrease. If you want to find the decrease, we look at our function and you realize you don't know what it looks like, so you go to the calculator and you graph it. When you graph it, you're looking for what the curve is, and if you're looking for a decrease, you're looking for where does the guy run. Again, I don't have the calculator in front of me, but let's say you have something that looks like that. You would be looking for what is this x value if I'm looking for the decrease, and what is this x value. Your options start from negative infinity, then you get x values eventually to infinity. If you're looking for the decrease, in this example, again, it's not the exact function shown. Let's say this was 1 and this was a 4. The decrease would start when he has ran to the number 1, and it would keep decreasing until he ran to the number 4. In the next one, which of the following does not have a domain of all real numbers? The first one's an absolute value. It's in the shape of a V. It has a domain of all real numbers. Second one is a line. It has all real numbers. The last one is a quadratic. It's a parabola. It's all real numbers. Choice C is a square root. It looks like this, and that's the one where x is always greater than whatever the shift had been for the graph. So the one that does not have the domain of all real numbers is choice C. What is the number of turning points in a graph for the function defined below? Again, it says the turning points. In this particular one, it's quadratic, so we have the shape of a U. That means this thing turned once. For something with a larger exponent, the rule for the number of turning points in a graph was 1 less than the degree, and the degree is the biggest exponent in the equation that they give you. What are the apparent zeros of the function shown in the graph? The zeros are where your graph crosses the x-axis, and it can be called zeros, roots, answers, solutions, intercepts. In this case, it crosses at 4 and at -2. Choice B. If y varies jointly with x and z, what is the constant of proportionality? This is a variation question, but it's a little bit different because this one they're only asking you to find the constant of proportionality. In other words, they're asking you to find k. So I start and I try to find an equation, and it says y varies. So y equals, how does it vary jointly? So in your mind it's going to be k and then something something. In this case, something something is x and z. So I write these down. It says, what is the constant of proportionality when y is 30, x is 4, and z is 5? So that would be 20. And I'm solving for k, so I would divide this over. 30 over 20 is equal to k, and 30 over 20 is the same thing as 3 over 2. So again, in this particular problem, we were just looking to figure out what k was. In other variation problems, there'd be one additional step, so you want to read the directions and see what they're asking you to look for. In the next one, it says, which value of x is a solution to the equation below? I want to solve for x, so I want to undo everything that is around it. The first thing I want to undo is the 4. Currently it's being divided by 4, so to undo a division of 4, I would multiply by 4. So the root of 2x plus 2 is equal to 12. And you want to take note that the plus 2 in this particular problem is not underneath the root. So we want to subtract 2 from both sides. The root of 2x is equal to 10. And now to undo this root, you need to raise it to the power of the root. It's a square root. So to undo a square root, I square both sides. 2x is equal to 100. Divide by 2. X is equal to 50. A graph is given and it has 5 questions. The first one says, where is g of x equal to 0? G of x is the same thing as f of x. It's the same thing as y. They're asking where is y 0? This is just another way of saying where are the roots, zeros, answers, solutions, crosses at -3 and at +1. You could also write these as an ordered pair as -3 comma 0 and 1 comma 0. What's the y-intercept? The y-intercept is where it crosses the y-axis. That happens at an ordered pair of 0 comma 3. What is the domain? Domain is your x values. It's a parabola, all real numbers. What is the range? Range are your y values. Its highest value is at 4 and going down. So y is less than or equal to 4. What is the end behavior? As x goes to infinity, f of x goes to -infinity. As x goes to -infinity, f of x goes to -infinity. So as x goes in both directions, y is going down. Given that f of x is this and g of x is that, find g of f of 2. This one asks me to plug 2 into f and then that into g. If I plug 2 into f, I'm at -3 times 2 is -6, and -6 plus 4 is a -2. So f of 2, when I plug this in, is -2. And then I want to take that -2 and plug it into g. So if I take -2 into g, -2 plus 7 is c, 5. Which equation represents the statement? R is inversely proportional to S and directly proportional to the cube of t. So you want to do this problem in two different ways, and you kind of want to split it here at the word and. If I just said to write R is inversely proportional to S, and we stopped at that, we would say R is inversely proportional, so it's K over something, it's inversely proportional to S. Now if I read this problem again, but ignored the first part and said R is directly proportional to the cube of t just means t to the third. So if it's directly proportional to the cube of t, we'll pretend this isn't here right now. R is directly proportional to the cube of t. So you're doing two things at once. You're doing anything directly or jointly would be up top. Anything inversely would be on the bottom. So reading the whole statement. R is inversely proportional to S. We're showing that. And it's also directly proportional to the cube of t. We're showing that. So that takes you to choice D. What is the solution set to the equation? We see it as quadratic. We know when it's quadratic, we're thinking about factoring or quadratic formula. You look at this one for a second and you realize it does not factor. So, quadratic formula. A, B, C. A is 1, B is -2, C is +5. So negative B, but B is already negative, makes it a +2 plus or minus. The square root of B squared is 4 minus 4AC over 2A. 2 plus or minus the square root of. There's only one negative underneath this, so we're going to be subtracting. It's 4 minus what? 20 gives us a -16 over 2. -2, which was a positive, plus minus the square root of -16 gives us 4i. So this is 2 plus minus 4i over 2. Final answer, divide them all by 2, and we have 1 plus minus 2i, not 3i. 1 plus minus 2i, choice H. The only thing different with choice H is that instead of saying plus minus, they split them up and wrote them individually. What are all the roots for the following equation? It's an absolute value. To solve an absolute value, you take the stuff in the brackets and set it to your number, and also set it to the negative number. So 2u minus 9 is 5, and 2u minus 9 is -5. Solving each, 2u is equal to 14, u is equal to +7. Solving the other one, I add 9. 2u is equal to 4, u is equal to positive 2. So we have 7 and positive 2, choice J. The time it takes to do a job is inversely proportional with the number of workers. I would want to stop right there. You know it's a variation problem. It says the time it takes to do a job is inversely proportional. So that's telling me how it varies. It varies inversely. So I start over and I say the time varies. So time equals, it's inversely, so K over, what is it inversely varying with? Workers, W. So T equals K over W. We keep reading. If 8 workers can do a job in 6 days, so 8 is W, 6 is your time. So 6 is equal to K over 8. We always want to solve for K. I multiply both sides by 8. K is equal to 48. Keep reading. Then 16 workers could do the same job in, so they're asking us to find the time. So T equals, we know K is now 48, and they're telling you to use 16 for the number of workers and solve for T. T is equal to 48 over 16. T is equal to 3. Assuming the domain of the set of all real numbers, what is the range? This problem is just saying, what is the range? They've given you x squared plus 2. In your mind, you have a parabola that is 2 units up, and they're asking for the range. This would be going from 2 all the way up. So the range is, choice J, all real numbers greater than or equal to 2. What is the apparent solution set for P of x is equal to 0? P of x, f of x, q of x, all meaning the letter y. This is saying where is y 0? Just another way of saying where are the roots, the zeros, the answers. Where does it cross the x-axis? Happens at negative 2, happens at positive 2, choice F. The graph of y equals 4x minus 11 is translated up 8 units. So 4x minus 11 is a line. So that's the line of 4x minus 11. And I want to move this up 8 units. You have to think about what you have in a line. 4x, mx plus b. 4 is your slope. So I wouldn't want to change my slope. That wouldn't move it up 8 units. That would just change my line in the direction that it goes. If I want to move it up 8 units, the back number is your intercept. That's going to be the one that controls the up and the down. So if I want to move this line up 8 units, I should add 8 to the negative 11. And when you add 8 to negative 11, you have choice J, 4x minus 3. Which is equivalent to the expression below. They're asking you to FOIL. First times first is 3. The outer is I. The inner is 9i. Last times last is plus 3i squared. Combining like terms in the middle, you have 3 plus 10i plus 3i squared. We know that I squared is equal to negative 1. So this entire back term is really a negative 3. We have a positive 3 and a negative 3. So these cancel. Final answer, 10i. Which graph most accurately represents the following function? In other words, they're giving us this graph of the absolute value. They want to know which equation represents it. This absolute value is 3 to the right, and it is 2 units up. So to do a left and right shift is your opposite. So I want to say x minus 3 in the brackets. For 2 up, I want exactly plus 2. Choice B. Question asks for the x values of the solution for the system. If I'm going to do a system, they give me 2 equations. I need to solve them each for the letter y. I look at the first one. X plus y plus 10 is 0. If I solve that for y, I want to subtract the x, I want to subtract the 10. So for the first equation, I have y is equal to negative x minus 10. For the second one, I want to solve it for y. To get the x squared over, I would subtract it. To get the 2 over, it's already negative, so to bring it over, I would add it. Now we have 2 equations. You would want to put these on your graphing calculator. When you do that, again, I can't show you the calculator, but you get something that looks like this. And you see one intersection right somewhere down in here, a little lower than this. And then you see that a second one is coming. If you could see lower on the graph, that's when we went to the window. We changed the window so that you could see more down. That was called Y min. When you do that, it connects the graph for you. You can see two intersections. One's happening here, one's happening here. To find the intersections, you go to the calculator and hit second trace, calculate. The fifth option is intersection. Then you do first curve, second curve, so enter, and then before you hit it a third time, you line up your guess. You hit enter a third time. You get -3, -7 for the first intersection, but I don't want that as an answer because this question just asks for the x values. It could also ask for the y values, or it could give you complete intersection overall. So this one had an x value of -3, and if you repeat the process for the other intersection, it has an x value of 4. Which is a solution for the following? It's the fourth root of that plus 11. First thing I want to do is subtract the 11. Now I have the fourth root of w minus 4 is equal to 3. Raise both sides to the fourth. So w minus 4 is equal to 3 to the fourth is 81. Add your 4, 85. Which is equivalent. This just says 13 minus what? What is my what? The square root of -81. 81 would go to 9, and it's a negative, so 9i. So 13 minus 9i. Choice G. What is the simplified form of that? When you have two radicals, not like adding and subtracting, when you multiply, you can put them together. Adding and subtracting, you must have the same number to add them or subtract them. Multiplying, you can just say this is the square root of 126, which was 6 times 21, and you break this down like any other number. You're looking for a perfect square times something. In this case, my perfect square is 9 times the something being 14 to get 126. The cube root of 9 is 3. The 14 is left over. Choice A. The next question says, click on the grid to plot the point that is a solution. So if this was an SOL question, you would be clicking on the graph for where your solutions are. It's a system. Your solutions are where the two graphs intersect. What is the factored form of the following? You see x squared, that's a square. I see 36z squared, that's a square. They're being subtracted, so you have the difference of squares. So a plus b, a minus b, choice F. What are the coordinates of the vertex of the graph of the function? Currently, it's not solved for y. If I want to solve it for y, I should subtract 5 from both sides. This would then give me -2 x minus 1 to the second power minus 5. Now that I know my equation, I'm saying, what is the vertex? The vertex, if I was to start graphing this, is 1 unit to the right. It is 5 units down. Choice H. Last question. A solution to the quadratic equation is 13 minus 11i root 7. Which of the following must also be a solution to the equation? If it's a solution to the quadratic equation, think about how your answers work out in the quadratic equation. If I tell you it's normally -b plus minus the square root of all your stuff over 2a, you get plus minus. So in this particular problem, they're saying this is a solution to the quadratic equation. They're just not giving you the plus minus. In this problem, they gave you the minus. It's missing the plus. All they're saying is, what's the other answer? So if they gave me 13 minus 11i root 7, the answer that's missing is 13 plus 11i, circle them both, 11i root 7. The only thing you're changing is the symbol in the middle. If it had said 2 plus 3i root 5, the part that was missing would have been the minus.